Let us discuss about the vortex induced vibration. So what is vortex induced vibration? And that's a physical phenomenon that occurs when a fluid flow, you can see this is the fluid flow, like wind past a bluff body. You see this kind of cylinder, a structure with a broad cross section such as cylinder, tower or bridge, and generates alternating vortices. You can see this kind of alternating forces. It sets this kind of alternative forces that set off in the body in a periodic manner. So these vortices create oscillating forces perpendicular to the wind direction. So it's moving downward this way and upward. There will be lateral forces like this. You can see these lateral forces. This upward move downward. So force is pushing downwards like this, and then goes upward, moves upward. So force is pushing like this. So it generates and creates oscillating forces perpendicular to the wind direction, which can cause the structure to vibrate sideways or twist. So how it happens, like mechanism VIV, wind hits the structure. So consider a cylinder pole. As the wind flows past, the flow separates on either side. You can see the wind is separating, wind flow is separating on either side. So vortex setting, vortices are set alternately from each side. So this side and this side, this creates alternately from each side. This creates a periodic lateral force. So you could see this is a periodic lateral force. The resonance, if the setting frequency, this frequency is close to the structure's natural frequency, then amplitude of vibration increases dramatically. Self-excited oscillation. The structure moves in response to these vortices, which in turn can reinforce the vortex setting, sustaining the vibration. So key parameters. The Struhel number. It's a dimensional number that relates the vortex setting frequency Fs to wind velocity u and characteristic dimension. This is the diameter, this wind velocity, this Struhel number. Fs is the setting frequency, Struhel number is 0.2 for cylindrical, u is the wind velocity, d is the cylinder diameter. We have to see the reduced velocity. If dimensionless number, that's comparing the wind speed and to the structural natural frequency. So Fn is the natural frequency of the structure. VIV becomes significant at certain VR values. Amplitude of vibration that depends on wind speed and structural damping. Effects on structures. Oscillating motion causes fatigue and structural failure over time. This is common in towers, chimneys, and bridge cables, high-rise buildings, transmission lines. Typical VIV response will be small lateral oscillations at moderate wind speed, potentially growing if resonance occurs. You can see the fluid flow is this way, and the pipe vibration is lateral to that. These are the vortex setting in the wake. It's causing this. A pipeline example.